Good afternoon, Alvin ISD Geometry boys and girls. Today we're going to learn about areas of similar figures. If two polygons are similar, then their perimeters are proportional to the scale factor between them. So the ratio of the new similar figure over the original similar figure is equal to the scale factor, or K. The actual areas of two similar figures have a different relationship. Since we have affected more than one dimension by the scale factor, the ratio of the areas of two similar figures actually become the scale factor squared. So here we come to our first theorem. If two polygons are similar, then their areas are proportional, which means equivalent ratios, to the square of the scale factor between them. So if ABCD is similar to FGHJ, then the ratio of those two areas is equal to the scale factor squared. So we want to find the area of our similar polygons. So we're told that triangle JKL is similar to triangle PQR, and that the area of triangle JKL is 30 square inches. Now our unknown is the area of triangle PQR. So I know that these triangles are similar, and it says we want to find the area of triangle PQR. So I'm going to look at the corresponding sides, and I can find my scale factor by putting 15 over 12. So I'm going to come to my work over here, pull it down just a little bit. So when I put 15 over 12, that simplifies to 5 over 4. Now this is the scale factor itself, but since we're talking about area, they're related by scale factor squared. So I will square the scale factor to get a value of 25 over 16. Now this 25 over 16 is the relationship between the two areas, and I have the known value of triangle JKL, so the 30 will go down to the bottom, and then this will be my unknown. So I know that I can do cross multiplication and then division to solve for my unknown part. So I will multiply 25 and 30, and then divide by 16, which gives me an approximate value of 46.9 for the area of triangle PQR. So then we're going to go back. Let's check our work. So the scale factor, just like we did, we set it up of PQR over triangle JKL, and we got 5/4. But since the ratio of areas is scale factor squared, 5 over 4 squared gave us the 25 over 16. So we multiplied it by our 30 to get the approximate 46.9 square inches. So now for these two pairs of similar figures, we want to find the area of the green shape. So again, come back to the work page. So our first one will be 1A. Move this up. So I know that we're going from blue to green, so the ratio will actually be 5 over 8. But since we're looking at area, again, I need to square that. And when you square a fraction, you square the numerator and the denominator. So we get a value of 25 over 64. And I am solving, for the area of the smaller shape, so the 5. So my unknown goes in the numerator. My denominator will go on the bottom, which was the 32, because we're looking at the area. So right off the bat, I see this multiplicative relationship of dividing by 2. So I know I don't even need to use cross multiplication. And so I get that x has a value of 12.5 centimeters squared, which represents the area of triangle, the green triangle with the dimension of 5 centimeters. So now we're going to look at 1B, and we're going to set it up the same exact way. So 8 over 6 represents my scale factor. I'm going to go ahead and simplify that to 4/3 just to work a little bit smarter and with smaller numbers. And again, since we're looking at area, I will square that scale factor to give me 16 over 9. So then when I set up my proportion, so 16 over 9 would need to be equivalent or proportional to the area of the smaller triangle with the dimensions of 6, which I know is 13.5, and the area of the green triangle. So I will cross multiply, so 16 times 13.5. Then I would divide by 9 to get my value of x. So we're going to come over with our calculator. So 16 times 13.5 divided by 9 gives me a value of 24. So 24 represents the area of the green triangle. So now we want to use areas of similar figures to find the scale factor of missing measures. So I'm given that the area of parallelogram ABCD is 150 square meters, and then the area of parallelogram FGHJ is 54 square meters. So if they're similar, that means that the relationship between their areas must be equivalent to scale factor squared, and I'm trying to find the unknown value of segment JH. To find the unknown segment, I need to find the actual scale factor. So I'm going to use the information I know about the area relationships to solve. So move this up. So I know that ABCD, or the larger one, is 150. And that over the area of FGHJ, which is 54, must be equal to the scale factor squared. So I'm going to simplify this fraction. This fraction simplifies down to 25 over 9. So again, we're still looking at scale factor squared, but I need to know individual scale factor. So if I take the square root of both sides, I get that my scale factor is actually equal to 5/3, which would be the relationship between the two sides. Move this down just a little bit. So if 5/3 represents the relationship between the dimensions of parallelogram ABCD and parallelogram FGHJ, then when I set up my second ratio, x will go in the denominator and the 10 will go in the numerator. And again, an easy multiplicative relationship of multiplying by 2. So the value of x, which is my length of JH, is actually going to be 6 meters long. So now for each one, it's going to be the same exact situation. So we're given this pair of similar figures, and we need to use the area to find a scale factor, and then apply that scale factor to solve for a missing dimension. So I will set up my ratio. So scale factor squared is equal to the ratio of 72 over 50. And I know I can simplify this to 36 over 25. To go from scale factor squared down to just the original scale factor, you'll take the square root of both sides. And again, when you take the square root of a fraction, you're taking the square root of the numerator and the denominator. So your scale factor becomes 6/5, which I can now use to go plug and create a proportion. So 6 over 5 represents the green trapezoid over the blue. And I know the green trapezoid has a dimension of 6, and this is my unknown. This is a one-to-one relationship, so x is just equal to 5 inches. Right, another example 2b. So we're given, two kites, and we're given their areas. So come up here, move this over so you can see. Okay. When I go to set up the ratio of scale factor squared for these two kites, I'm automatically noticing that both of the areas are already perfect squares. So even though they are going to be divisible by 2, I probably don't want to simplify that yet. Although you could, and we would still get the same correct answer. So I will put the area of the green diamond or kite over the area of the blue. and then I will take the square root of both sides to get my scale factor of 8/20. Well, now these numbers are going to be a lot simpler to do mental math with and simplify. I see that I can divide both numerator and denominator by 4 to get an equivalent fraction of 2/5, which is going to be our scale factor, or our K. And so then using that, I can set up my proportion of 2/5. Now 2 representing the dimension of the green kite. So that is my X value, that's my unknown. And then the 40 goes in the denominator. And again, easy multiplicative relationships. 5 multiplied by 8 gives you the 40. So 2 multiplied by 8 will give you your unknown value of X, which would be 16 millimeters long. All right, dimensional changes. When you change the dimensions of a figure, and they're changed proportionally, then the new figure is similar to the original figure. So we have Orlando and Mia. Now both of them have a garden. Now both of their gardens are 12 by 15, but they plan to expand them. Orlando's new garden will measure 18 by 22.5 feet, while Mia's new garden will measure 18 by 18.75 feet. We want to describe how these dimensions are changing the areas. I'm going to come back. First thing I want to do is, if I'm looking at Orlando's garden, both Orlando and Mia had original dimensions that had a relationship of 12/15. 12/15. Now, for the new gardens to be similar, they would have to be proportional to 12/15. So they would have to be equivalent. So when you divide 12 by 15, you get a value of 0.8. So both those original dimensions had a value of 0.8. So the new dimensions, for them to be proportional, would have to be simplified to the same value. So Orlando's became 18/22.5. And Mia's were 18/18.75. So we're going to go use our calculator. 18 divided by 22.5 gave us 0.8. What this means is that the dimensions were changed proportionally. So his new garden, so that was a proportional change. Which means the gardens are similar figures. So I'm kind of thinking that Mia's are not going to be proportional, but we need to still prove it with our math. So we'll go and we'll take 18 and divide it by 18.75 to get a value of 0.96. Now, since these ratios are not equivalent, that means that it was not a proportional change, which means the two gardens are not similar. So not similar gardens. And they left it in fractional form. That's another strategy and way that you could do it. Orlando's garden still simplified to that ratio of 3/2, while Mia's went from 3/2 to 5/4. Since Mia's did not increase by the same scale factor, it was not a proportional dimension change. So now we have our last problem. We have Miyoki is crocheting 2 circles. The diameter of the smaller circle is about 8 centimeters, and the diameter of the larger circle is about 12.6. We want to describe how the difference in dimensions affects the area of the circles. So we have our first circle with the diameter of 8, and then we have our larger circle with the diameter of 12.6. Now I know that area is related by scale factor squared. So 12.6 divided by 8, and then that quantity squared, gives me a value of approximately 2.5. This means that the area of this circle is approximately 2.5 times larger than the smaller circle. Thank you so much for learning today, boys and girls.